Hello students. So in the last class we have discussed about the numericals, how to find directivity. So using isotropic point sources with the directivity and formula. So today in this class we will continue with the more topic, that is array of two isotropic point sources and its relations. Consider the 2 points of source, point 1 and point 2, separated by distance d. So let's consider one observation point P. So at a distance r from origin with an angle psi. So that distance is what? R, and then psi is the phase difference. We'll see here one by one how exactly it is. Pattern can be improved by changing the design or by increasing the number of array elements. So these are the array elements. So we can change the pattern. So in this context, consider two isotropic antennas which will radiate the power in all directions equally. Hence, to measure the power pattern emitted by that can be calculated. Consider an array of two isotropic point sources here. So in this case, these are the two isotropic point source 1 and 2. So separated by distance d, and P is an observation point which creates an angle phi, by varying we can measure the power pattern. So both P and phi can't be varied at a time. So the line from point source 1 and 2 to the point P shows the phase difference. Phase, psi is the phase difference between the 2 point source. Psi is the rotational angle between the point P and x axis. R is the distance from origin to point P. D is the distance between the 2 point source. Dr will be the distance between the 2 point source in radians, right? So this is about the background. So we define a cos phi from the triangle, that is psi by 2 dr by 2. So cos phi will be psi dr. So where dr will be 2 pi by lambda into d, right? So where dr will be beta d, where we can write 2 pi by lambda as beta, where beta is the phase constant, that is 2 pi by lambda. So therefore psi can be written as dr cos phi. So this will be psi will be dr cos phi. We know that what is the dr? It will be beta d or 2 pi by lambda d cos phi. So this is the basic formula for our next coming discussions, right? So now we will discuss some cases in this case, right? So we have this formula, that is psi will be dr cos phi, or psi will be beta d cos phi, or psi will be 2 pi by d cos phi, right? So case 1, two isotropic point sources of same amplitude and phase, where the distance between the 2 point source will be lambda by 2, right? Now consider these two. So these are the two vectors, that is E0 e raised to j psi by 2 from point source 2. So E0 equal to e raised to minus j psi by 2 from point source 1. So resultant will be psi, this will be what? E with an angle psi by 2, right? So total field at a distance r in a direction at angle phi, considering a origin as a reference, therefore E will be equal to E0 plus E0, that is E0 with respect to a point source 2 and point source 1 each, right? E0 e raised to j psi by 2 plus E0 e raised to minus j psi by 2, right? So therefore it will be what? Multiply 2 and divide by 2, so numerator as well as denominator. Therefore, so e raised to j psi by 2 plus e raised to minus j psi by 2 by 2. This results in what? Cos function. So where function will be what? Psi by 2. This 2 E0 will be as it is, right? So this will be what? So in the complex representation we can write that one as cos theta. So here theta is what? Psi by 2. So 2 E0 cos psi by 2. Let E0, 2 E0 will be 1, means maximum value we are considering is what? 1. It is called normalizing. Therefore E will be cos psi by 2. So now next thing is that E is equal to cos psi by 2 is there. What is psi? Dr cos phi. So we have already seen that. Psi will be what? Dr cos phi, right? What is that dr? Beta d. What is that beta? 2 pi by lambda. That those things we need to substitute here. Dr cos phi by 2, right? So we need to simplify this one. What is this one? Dr, right? So we know that psi will be what? Dr cos phi. So therefore dr will be 2 pi by lambda into d. 2 pi by lambda as it is. D is that lambda by 2, distance between the two observation point. So lambda will get cancelled, 2 and 2 will get cancelled. Answer will be what? Pi. So in the place of dr, so we should substitute what? Pi. So therefore E will be cos pi by 2 cos phi. So therefore when phi is 0, so in this equation if I substitute phi as 0, cos 0 will be what? 1, right? It will be 1 cos pi by 2. Cos pi by 2 is how much? 0. So therefore E will be 0 when the value of phi is what? 0. Similarly, if you substitute phi as pi by 2, cos pi by 2, what is the cos pi by 2 value? What? It's a 1. So it will be, it's a pi by 2, right? So cos of pi by 2, it will be 1, right? Therefore phi value will be what? Pi by 2. So corresponding E value will be how much? 1. This is how the radiation pattern of two isotropic point source with the same amplitude and same phase. So resultant pattern will be, see, for theta or angle 0, so the E will be what? 0, means field will be what? 0. For this angle 0, so fields will be 0. When angle is 90 degree, see 90 degree, so field will be maximum. Similarly for 270 degrees, the field will be a maximum. Similarly for 180 degree, field will be 0. See, these are the two isotropic point source, so 1 and 2. The conclusion of this one will be, so radiation pattern will be more along the vertical axis, means at the angle 90 degree and 270, and pattern will be at minimum or will be 0 in the angle of 0 degree and 180 degree, right? So let's move on to the case 2. Same amplitude and opposite phase. Two isotropic point source, the same amplitude and opposite phase. Here E will be E naught e raised to j psi by 2 minus E naught e raised to minus j psi 2. This is the difference between the previous and this one. Now what I will do here is multiply 2j and divide by 2j to the numerator and denominator. That doesn't make any difference. 2j E naught as it is. So what is this one? This will be a sine function. So e raised to j psi by 2 minus e raised to minus j psi by 2 whole divided by 2j will be what? Sine theta. So what is the theta value here? Psi by 2. Therefore E will be 2j E naught sine psi by 2. Right. Let 2j E naught, let it be what? 1 for normalizing, means maximum value. Right. Now further we will see E will be sine psi by 2 now. So if I consider this one as unity, means 1, so E will be what? Sine psi by 2. Therefore E is equal to sine, what is the value of sine? Dr cos phi divided by 2. So what is this one? Dr. So we know that distance between that d will be what? Lambda by 2. Dr will be 2 pi by lambda into d. Substitute here all the values, lambda and this 2 will get cancelled, dr will be phi. Therefore E will be sine, the place of dr write pi, right? So pi by 2 cos phi. Therefore, so we go on substituting the value of phi here, so get the value of E, right? Now see so when the value of phi is 0, cos 0 will be what? 1 into pi by 2, sin pi by 2 will be what? 1. Therefore E will be 1 when phi is 0. Similarly substitute the different angles. Say phi is equal to 90 degree here. So cos 90 degree will be what? 0. 0 into pi by 2 will be 0. Sin 0 will be what? 0. Therefore E value will be 0 when phi value will be what? 90 degree, right? Next pattern we will see that. So you can see fine, angle is 0 degree, the field will be what? Maximum. See, This is what the two isotropic point source. For 0 degree and 180 degree, so the field will be maximum. For 90 degree and 270 degree, so field will be minimum. This is how the two isotropic point source with the equal amplitude and opposite phase pattern, right? So third case, you will see a same amplitude and quadrature phase, that is 90 degree phase. So E will be what? E naught e raised to j psi by 2 plus pi by 2 plus E naught e raised to minus j psi by 2 plus pi by 4, right? So point source 1 has pi by 4 leading and point source 2 has pi by 4 lagging. Overall phase that results in what? Pi by 2. Therefore, so I will multiply here 2 again, divide by 2, it's a 2 E naught e raised to j psi by 2 plus pi by 4 plus e raised to minus j psi by 2 plus pi by 4 by 2 whole. This one, what is this one? So since we are having the plus sign, same theta, divided by 2, it's a cos function. Therefore, E will be 2 E naught cos psi by 2 plus pi by 4. Let 2 E naught will be what? 1. So for normalizing, so remaining will be what? E is equal to cos psi by 2 plus pi by 4. We know that psi is what? Dr cos phi. So dr will be given 2 pi by lambda into d, where d is lambda by 2. This lambda and 2 will get cancelled. Dr will be what? Pi. In the place of psi, so write pi here. So pi cos phi divided by 2 plus pi by 4. Now the task is that let E will be what? 1. Find so psi. What is the value of psi? Right. So for E to be 1 means, for this one to be a 1 means maximum, what is the angle of phi? That we need to find out now. So 1 is equal to cos pi by 2 cos phi plus pi by 4. So this will be cos inverse of 1. So if I take left hand side, cos inverse of 1 will be what? 0. So right hand side, so I will get pi by 2 cos phi plus pi by 4. So I want to get the value of this phi, right? So take this one this side, minus pi by 4, pi by 2 cos phi, just multiply. So this one 2 and pi will get cancelled, minus 1 by 2. Cos phi will be what? Minus 1 by 2. So what is the value of phi? To get minus 1 by 2 as a cos function, so phi will be what? Cos inverse of minus 1 by 2, that will be 120 degree or minus 120 degree for maximum value of what? E. Now see this is the maximum value. The pattern will be maximum when a theta is 120 degree as or minus 120 degree. Let E to be 0. For field to be a 0, what is the angle of phi? So equate it to 0, 0 cos pi by 2 cos phi plus pi by 4, right? So cos inverse of 0 will be what? Pi by 2. Pi by 2 is equal to pi by 2 cos phi plus pi by 4. Pi by 2 minus pi by 4, that will be what? Pi by 4. Pi by 2 cos phi is equal to pi by 4. So this will get cancelled, 2 and 2. So 1 by 2. So cos phi will be what? 1 by 2. So for cos phi to be a 1 by 2, what is the value of phi? Cos inverse of 1 by 2, it will be what? Plus 60 degree or minus 60 degree. So therefore pattern it looks like, see the field will be maximum when 120 and minus 120. So 120 degree minus 120 degree, and minimum, that is what? Nulls. These are called nulls, where the field will be what? Very minimum. So those are called nulls. So that the angle is what? 60 degree minus 60 degree. So this is all about the field pattern. So when the three cases we have discussed, when two isotropic point source with the same amplitude, same phase. Second case, same amplitude with a different phase. Third case, what is that? Same amplitude and quadrature phase, that is the phase difference of 90 degree. Okay, so rest of the things we will discuss in the next class.